Okay, so we're going to start talking about chapter 6. So I'm going to start with the PowerPoint side, and then we'll take a look at a bunch of different programs to try to figure this out, make sure everyone's okay. But I want to explain some concepts to you and talk about some things. So again, one of the reasons why we picked Java is because it's object-oriented from the very start. Everything, objects are mixed into everything, which is not really true in C++. In C++, you can do it without the objects, but you can add the objects in later. But Java is very object-oriented, and so that's why we use it for this class. But you may not have understood what you were doing completely, but hopefully after we start talking about objects, you can go back and everything will kind of make sense from there as we, talk about different things. And eventually everything will fall together. Okay, so when we talk about objects, we're creating an object. Objects have properties. These can be called a number of different things. Sometimes people call them fields, properties. It's basically like if you were talking about a person as an object, okay? What different things would you care to know about this person with what you were doing? Now, you don't have to do every possible property if it doesn't relate to your system. So if you're talking about like a person, what information do you need? Maybe depending on what you're doing, you may need like their height and weight, depending if you're doing a calculation with that. But if you're not, like if it's about their bank account, you probably don't need that information. Probably just like their name and, identification number. So what information do you need? Those would become your fields. Those are your properties about the object. Okay, so we call this a blueprint. When we're creating a class, we're creating the layout for the object. We call it a blueprint. So think about a blueprint like when you're building a house. You don't just start laying bricks together, right? Hopefully you have a layout before you do that. You don't just like start laying bricks and say like, oh, I guess this will be the kitchen and maybe we'll lay some bricks over here for the bedroom. Hopefully you draw a nice little architectural layout of what's going to happen and you think about it ahead of time. That would be your blueprint, right? So you have a blueprint for building that house. But once you create that blueprint, you can create many houses based on that blueprint. So it doesn't have to just be one house. It can be, if you have a community, you might have, 10 different blueprints, but you can create like 100 houses from those. You could just say like, okay, which blueprint did you want? And we'll build that house. And then which blueprint did you want? These are the options we have. And, some might have the kitchen over here and the bedrooms here, and then some might move it, a different way. And so we can create many objects based off one blueprint. Okay. And so again, you might just create one object on the blueprint, but you can create as many as you need. Okay. To be fancy, whenever you create this object, like let's say you have this blueprint and you're building the house, we call it you're creating an instance, okay, of the class, which is called instantiating the class, which is basically creating an object. So you're building, you have the blueprint for the houses, but when you actually build the house, that's called an instance of the class, an instance of the blueprint, or instantiating a class to be fancy. But it's just creating the object, actually building the house. Okay, so you kind of get used to this terminology. When someone says instance, that just means object. Same thing. Okay, and class is your blueprint. So when we say class, that's your blueprint. Instance is the object. Okay, so if you're instantiating a class, which sounds really fancy, you're building an object. You're creating an object of the class. That makes sense to everybody? So I'll try to throw these words out there so you get used to them. Okay, so one of the objects that we've used so far is the scanner. Okay, I know that it sounds, some of the things in Java are objects and they're kind of abstract. Like we don't really think of them as objects, but we have to kind of examine the code that we've been using. So anytime you see that word new, that means you're creating an object. So that new word indicates that you're creating an object. So here says that this part says that the name of the class is scanner. This is the name of the object. That's a variable name. It should follow the variable naming rules. It should start with a lowercase letter, and it can be called anything you think makes sense. Okay, so if we're creating a scanner object to take an input, I usually call it input or keyboard or something like that. So that's just a name. It can be any name you want. Okay, this part just declares that you're going to have a scanner object, and the name of it is keyboard, but it doesn't actually create the object yet. So you could say scanner keyboard semicolon if you want to, and that's just a declaration, just like you say int number. It says, okay, I have a variable that's name as number and it's an integer. This says I have an object, its name as keyboard and it's type scanner. That's how you're going to know how to create it, but it didn't actually create it yet. Okay, but then the new scanner, the second part here, actually creates the object, and it tells it sometimes when you create the object, you'll have something in parentheses and sometimes you won't. If it needs data in, to create the object, which we'll talk about when it needs data and when it doesn't, then you put something in parentheses. So this one needs to know where is that data coming from, and it's coming from the keyboard. So you say system in means that it's coming from the keyboard. Okay. Now, if you wanted to do it as 2 separate lines, which I usually don't do, but if there was a reason why you want to declare that you have a scanner object and then later create the object, not create it at the same time, you could say scanner keyboard semicolon, and then later you would say keyboard equals new scanner system in. But normally you just do it all at once because normally you just want to say that you have it and create it all at the same time, unless there's a reason for not creating it yet. Okay. We didn't really use this. Your book uses this way. I use the math.random when I'm doing random numbers, but your book uses the random object. So if you use the one from your book, then you would have used this one, which is actually creating an object. I tried to stay away from objects as much as I could, but again, they're really just mixed into everything. So you really can't stay away from them. But this one is also an object, and it says that the name of it is rand. That's the variable name, the object name. And this says that you're creating, the type is random. And then this is creating, and we were talking about this, it could be empty parentheses if no data is coming into the object. Okay. We don't really use the print writer in here, but it talks about it in the looping chapter. So the print writer is another example of an object, and all it is saying is that the data type is print writer. This is the name of the variable. Okay. This creates the actual print writer object, and then how does it know the name of it? You put it in parentheses there. So numbers.text is the name of it. Okay, so again, sometimes you'll have something in parentheses if it needs information from you to create the object, and if it doesn't, and again, we'll talk about, we are going to set that up when we set up our classes, what information we need and what we don't. Okay. So we're going to talk about something very general, something very basic. We're going to talk about a rectangle. Okay. So what properties, or what would we care about a rectangle? Well, we are just going to do like the width and the length. Could you do like the color of the rectangle and everything? Yeah, but it's not something that we care about to do our calculations. So there are other properties of a rectangle, but we only care about the length and width. Okay, so we only put the properties that we care about in there. So these become our what we call fields, okay, for our object. So if you create a blueprint for creating a rectangle, you create fields. And when you create a rectangle object, those fields, those properties that you have, they go with the object. So like if I create a rectangle, those attributes or fields that you have would be with that rectangle. So if I move that rectangle somewhere, if I move it into a method, the fields go with it. It goes everywhere the object goes, okay? And then if I create another rectangle, the fields are saved with that object. And if I create another one, the fields are saved with it. So that information is held with that object. Does that make sense to everybody? Okay. So this is kind of tricky, and it takes a while to get used to. And when I was first introduced to it, I wondered why we had to do all this work. So I'm going to try to explain it the best way that I can, okay? We have these methods called setters and getters. Okay, that's typically what I call them. Your book also refers to them as accessor or mutator methods. I don't really call them, but you can, and we'll talk about that in just a bit. But in a general sense, we have these setters and getters, and the purpose of them is to modify these fields that we have. Like the setter's job is to change the fields. So like if we set the length of the rectangle at 5, but we want to change it later to 6, then we have a set length field, a set length method that can change that. Okay. And then we have a set width method that can change that. Now the getters return the information for us. So if I want to know what is the length of this rectangle, then I say get length and it returns it. And if I want to know the width of this rectangle, I say get width and it returns it. And you might be saying, why do I need to do all that? I have the fields. Can I just use the fields? Can I just put it directly into the field? And we'll talk about why that isn't a good idea just a bit. So another method that we have that we need to think about are any calculations that we're trying to do. So if we're trying to calculate the area, we have a get area to be able to multiply the length times the width. Okay. So we're going to talk about these more in depth as we go. Okay. So we are going to start looking at a diagram called a UML diagram. And the purpose for a UML diagram is to lay out the name of the class, all of the name of the fields, so those, attributes, those properties that we think are important, right, that we're going to have. And then to also have all the methods that we're going to have. So, what setters and getters are we going to have? What calculations are we going to have? What are we going to have? So the class goes at the top, and classes typically begin with a capital letter. Those are your file names. And before I was telling you, they start with a capital letter. classes start with a capital letter, and they can't be more, if they're more than one word, they can't have spaces in the name to push the words together. So with a class, if you have more than one word, you would push them together and just capitalize the first letter of every word. Okay? Then fields, and fields are your variables, so typically they begin with a lowercase letter. They would have a data type. So your fields, like if you're talking about length and width could be integers, for example. Or if you wanted them to be decimal numbers, they could be doubles. Okay, it just depends on what data type you think works with what you're doing. But we can also have booleans and strings and all the other data types. Okay, so all the fields are listed right underneath the class, and we usually put a line between them to separate. Okay, then all the methods you have, you put a line and you list all the methods. Now with the methods, we're not writing out like everything that the method does. Okay, we're just writing the name of the method, and we're also going to write, what data do we need, like what parameters do we have, and then what return type do we have, like is it we're going to return or not return. So some basic information about it. Okay, we'll start step by step though. We didn't write any of that information yet. Okay, so in a basic sense for UML, you would have the name of the class, which is rectangle with a capital R. These are the name of the fields, and I didn't say what data type yet. I'm going to do that later. Okay, and then these are the methods that we have. Okay, see the methods start with a lowercase letter most of the time. And then you have the parentheses, and again, we're going to talk about step by step, what goes in there. Okay, so if we're talking about the code for our class that we're writing, the name of the class was rectangle, right? So public class rectangle. We're going to make all our classes public. Okay, and then you have to write the word class and then the name of the class. Okay, now you have a curly brace to start your class and a curly brace to end. Your fields will go at the top of your class. Okay, this is where you need to think about the data type of your field. So if I want the length and width to be decimals, I would do double. If I want them to be integers, I could do ints, but the data type would go up there with them. The other thing you might notice is that it has the word private before each of the variables that you have. Typically, you want your variables that go with your object to be private. This is why we need setters to change them and getters to access them, because if they're private, talked about this before, you can't access it. Okay, so why do we make them private if you can't access it? Because that sounds strange. Like if we just take off the word private, you can access it, then you don't need setters and getters. So it's called data hiding or security. Reasons why we don't let people access things, everybody access everything, because then it's possible, like let's say in our setter, we want to validate that is not a negative number. Like for length and width, you can't have a rectangle that's negative, right? If we put validation in there to make sure it's not a negative number, and then somebody directly accesses it and makes it a negative number, then we got bad data in there. Okay, they didn't go through the setter to validate because they went directly to put it in the actual field. So if you don't want people to directly access the field, you want them to go through your validation to put values in, then they have to go through the setter to change the values. They can't go directly to the field if you make it private. And so typically, we want our fields that we have to be private, unless you have a reason for opening it up to everybody, because that's how you get bad data in your system. That kind of makes sense to everybody? Okay. So we were just talking about this. You can make your field public or private. If they're public, you don't need to really write the word public on there, because if you don't write private, then they're going to be public by default. So typically, your fields, again, should be private unless you have a good reason to make them public, okay? Because that opens up people to be able to access them and not follow all your validation that we're going to put in our program, okay? Now, your setters and getters, I don't like to say always, but almost always will probably be public, okay? Because you can't access them if they're private. So when you make this blueprint class, you're going to be accessing it from another class, another file. And we said that anything that was private in one file can be accessed from another file if it's private, right? So like the fields can be accessed if they're private, and it's good because we keep people out of them. But if we make our methods for our setters and getters private, then we can't access them. Okay, so that wouldn't be good. Then we can't change anything. So we want those to be public so everybody can access them and use them, because the way that you're going to change the values for the object is through the setters. And the way you're going to get information about the object is through the getters. And so they need to be public so you can do that. Okay. And then you're going to get used to this, but like setters are going to be void, because the purpose of a setter is just to change the information about the object. Okay, modify it, change it. So if you say that you have, for example, this is set length. If you say that the length of the rectangle when you create it is 6, but you decide later you want to make it 7, and you can't go through the field that you have because it's private. So you have to go through the set length method. So you say, okay, the name of the rectangle, set length, and then you say 7, and then it'll change it from 6 to 7. Okay. So because it's just changing the value, it's not giving you information back, then it's void. So setters are typically void because they're not giving you data back. They're just modifying the data you already have. Does that make sense to everybody? So typically your setters will all be void. Okay. And then to make it easy on everyone, whenever you're setting something, instead of one person calling it modify and the other person calling it change and the other person calls it set, we always just call it set, right? So it's always lowercase set, so everybody knows. So if I want to change someone's name, let's say I have people objects and I want to change someone's name, I could guess that the name of the method will be set name, right? And if I want to get their name, it's probably get name, right? It's pretty easy because it's usually just set and a property, get and the property. So we try to stay consistent with that so that when somebody's doing it, it's not confusing as to like someone called it modify and someone called it change. So, so set all lowercase and then the name of the property. So if we're talking about length, set length, okay? Then what information do you need? Now, typically setters will have information coming in because if you are changing something, you're changing a field, you need to have data to know what to change it to. So if I'm changing the length, I need to have a new length come in so I can change it, right? So I need to have a parameter of the new length that's coming in. And because it's a new length coming in, I need to give it a data type and I need to give it a name. So like LEN stands for length. So if I pass in 7, if I say set length and I pass in 7, 7's going to go into LEN and then I'm going to go ahead and change it. I'll show you how to change it in a little bit, but is everybody following so far? Okay. Now, we talked about the other day, we are going to try to put documentation on all of our methods. And if you do this after you create the method, like if you go up there and you put slash asterisk asterisk, and then you hit enter, it will fill in all your parameters for you. And all you have to add in is like the description of what the method does and a description of the parameter. But you don't have to remember all the tags because NetBeans is really good at filling that in for you. So I would do it after you create the method. So once you create the method, again here, this is where you would then go add the documentation for it. And then if you go to generate Javadoc, once you're all done, it'll create that nice little HTML web page for you. So you can see all your methods and then people can see the descriptions of it without actually accessing your code. Okay. So here you can see, we just talked about this, you know, that all your methods are going to be public for setters and getters. Setters, again, don't return. This is a common name for it. And then this is going to take in the length. Now, what's this going to do? This is going to set the length. And so assuming that you named that field length, it's going to set that field at the length coming in. So if you pass in 7, 7 will go into LEN when you call it, and then it'll take that 7 and it'll make it the actual field 7. Okay. Seems like a lot of work just to change the value of a field, and there's no validation in here. So you might say, couldn't it just be public and I change it directly? Well, if you're not going to add validation to ensure that it's not a negative number, then probably, yeah, because there's no difference between this and just changing the field directly. Because people can put bad data in here, just like they can put bad data into your field. But we'll talk about validation in a little bit. Okay, so we're starting like stepping stones. And so there's no validation. So you might say, I don't need to do this. But eventually we're going to add validation. So assuming we add validation, then this would be a better way to go. Everybody see that? Now, one thing that the slides talk about later, but I kind of want to mention now, and I'll mention again later as well, because I think the more you hear it, the better it is do you notice how the parameter name is LEN, but the field name is length? There's a reason why they're different. It's confusing if you make the parameter name the same name as the field name, because then Java doesn't know which we're talking about, okay? And so it's called shadowing, because now it has a field name length and it has a parameter. If you're in the method where the parameter is, it defaults to the parameter, not the field. And so if you say, like for here, if I said length, and then I said length equals length, it would just set the parameter as the parameter and it wouldn't do what I want it to do, right? Because it would just use the parameter. It doesn't know that like one is the field and one is the parameter because it can't differentiate between them because you gave them the same name. So we try to give them a different name. Now, can you give them the same name? Yes, but you have to do more work. It makes them more confusing. So if you decide to give them the same name and you want to refer to the field and not the parameter, you have to say this dot and then the name of the field, like this dot length. You'll see people do that. But if you forget to do that, then that method doesn't work. Okay, because it's doing the parameter equals the parameter. So what my recommendation is to just not give them the same name. Like, don't give your parameter the same name as the field. That makes sense to everybody? Try to, in it, you could just call it L. You don't have to, but I think sometimes people don't use L because L looks like one and it's like tricky. So LEN, so you know that's an L. Okay, now, whenever we actually want to create a rectangle, we use this code, and this should look familiar to what you had when you were creating the other objects, like a scanner object. So we say the name of the class. Remember, the name of the class was rectangle. So again, your class will start with a capital letter. Okay. Then you got to give it a name. So the name is option, like whatever you want it to be, right? Whatever makes sense with what you're doing. But it should follow the variable naming rules, like start with a lowercase letter. So like this one is called box. It could be whatever you want it to be, whatever object, you think name would be good. Okay. Then you would do equals new. This actually creates the object rectangle. And then we're going to talk about what this does in a little bit. Yeah, that's a constructor. So we'll talk about that. But so far, so good. If you don't have any data in there, because we haven't talked about how to put the data and how it goes into there, then it'll just automatically set these at 0 for you. Okay. Now, when you want to change them, like, because we haven't talked about how to set them when you're creating the objects, but we will talk about that. But let's say they're both 0 when they start off length and width, but you want to change them. You don't want them to be 0, right? So then you would say the name that you gave this object, which I called it box, right? So I would put box dot set length, okay? And then I would put what I want it to be. So like, I don't need to have 10.0, it could just be 10. It's not going to have a decimal number, but it's going to put, this is the length, so it's going to change the length. This would go in your main method, this code box. Actually, so would this would be in your main method. So you're going to have a class named rectangle that's going to have all your setters and getters and your fields. And then you're going to have a class that has your main method. And your main method is where you're going to create your objects and we're going to make changes to those objects. Everybody kind of following? Okay. All right. So then we have a getter. And I talked about this briefly, like what's the purpose of a getter? Well, if your fields are private, then you can't say box dot the name of the field to get the actual information about the field. So the only way to access that would be through a getter. So if you don't put a getter, then you can't ask like what the length or the width is of the rectangle if it's private. Okay. So you would need one for get length and for get width, and you would need it to be public so you can access it. Because you're asking for information, you're going to need to think about what data type you're returning. So if you're talking about length and width and you set those data types for length and width fields as a double, then you'll go with double as the return type. If you made them ints, you'll go with int, but just stay consistent with what you had. Okay. For getters, typically we don't have any data coming in because if you're asking for information about an object field, you don't need data to ask about the field. Okay, so you would have those empty parentheses. Okay. Then typically you'll just say return and the name of the field because that'll return the data about the field. So it seems like that'll work. Just to return like what the length of the rectangle is. But it's going to save us the security of people not modifying things and, without going through validation. So what's the purpose of it? Again, you would put your documentation up above it. Once you finish the method, you would just put /** and hit enter. And then that's where you can put a description. This is just whatever description you want to put about it. And then this would be automatically put on there. And because there aren't any parameters, you don't see the parameters here. There aren't any. But it does have a return type, so you can put whatever description you want for the return type, which is pretty obvious. But, if somebody's confused, this would be a great way to describe what's going on. Okay. Everybody okay so far? If you're confused about anything or have questions, just let me know. Okay. So this is a calculation method. So the other one that I showed you was just returning a field. Like get length is already one of the fields. You had a width and you have a length. This one is a calculation. So get area is going to multiply length times width and send it back to you. So if you ask for the area, you'll get it. Now, you might say, okay, well, why don't I just put an area variable as a field? And then I could just do the calculation there. It's usually bad practice to do that because you have to make sure that that data doesn't get changed and then never change again. So like if you change the length or width, you have to make sure that area field gets updated Okay, because if it's like an old one that was the old length and width, then it's not right, right? So it's better to usually go with a method that can take the fields values as they are now and calculate and give that back to you, as opposed to like having a variable that might never get changed. Okay, so, okay. I don't typically call it this. If you want to call it this, your book does call it this off and on. Everybody I know calls them setters and getters because that's just easier. Okay, but if you think like accessor is the way to access with your getters and mutator is how to change, okay? So if you hear someone say accessor and mutator, those are just setters and getters. Okay, so just a kind of fancy, I guess, if you want to confuse people, but setters and getters are usually a lot more down to earth, I guess. So I talked about this briefly. So data hiding just means making your fields private. Okay. So what else do we? Okay, so accessors retrieve, so that would be your getters, and mutator changes, so those would be your setters, right? So we would have, you know, it's up to you how you want to group these in your code. So when you're writing your code, if you want to handle each field, like if you want to do the setter and getter for that field and then the setter and getter for the next field, or if you want to do all your setters for all your fields and then all your getters for all your fields, that doesn't affect me which order you put them in. But your setters should always be, or should I hate to say always, because there's always like a weird case out there. My husband told me to stop saying always, because he'll find a weird case for me. But setters are typically going to be void because you're changing something. And then your getters will be returning. So usually you'll have a data type there for what you're returning. And then your setters typically will have parameter of what you're changing, and your getters won't because they're just getting information. So that's kind of, you know, as you get used to it and you do these over and over again, you'll kind of like just think like, oh, I know what that looks like. Okay. But, and you're always going to call them set. I shouldn't say always, but normally set and get, because it's common and people know what it is and whatever property name you're talking about. Okay. So security purposes, we have something called data hiding. Again, unless I tell you to make something, some field public, you should make it private, okay? Because there's a way that you're supposed to go through to change that, and you shouldn't just go directly. And if you make them public, means you could go directly and change them, which means that if you do add validation, that you're skipping all of that, okay? So we go through the setters to make changes instead of going directly to the variables, and so that's called data hiding. So again, unless you have a reason to make it public, we're going to leave it private for the field names. Okay. Now, something that we're talking about, and usually they ask this at an interview, and so it's good to know. It's like one of the common questions that you get is like if you're going for object-oriented programming, they'll ask like, what are the 4 pillars of object-oriented programming? And we're talking about the first one today. It's called encapsulation. Encapsulation means that if you think about like encapsulating something, okay, you're basically saying, you know, how you're going to access things. And so you're saying their fields are like public or private, allows you to hide the data and access it another route. And you're basically setting up a template for creating this object. And you get to say, you know, what is accessible and what is not accessible. And so this concept is called encapsulation. And that's the first, you know, pillar of object-oriented. The other 3 we're going to talk about later. But that's the first one, is setting up this template and encapsulating our data. Okay. And so you learned the first pillar, right? Kind of, and we'll practice it a lot. But we talked about this. Typically, if you're going to have calculations, you don't put them as fields at the top. Typically, they're just methods that do the calculation. And again, that's because depending on how you do it, you always want to make sure that those get updated, that they're not just like calculated one time and then you make changes to the, you know, the fields that are supposed to be doing the part of the calculations and they don't get updated. Like those fields that have the calculations don't get updated. So if you have the calculations in a method and you tell it to get area, well, then it's going to use the length and width of what it is now. But if you have that up at the top and you tell it when the object is created to do it, but then later you change it, then it never gets updated. Okay. Okay. So again, we have this get area. Does that make sense to everybody so far? Anyone have any questions? Okay. So I talked to you about the way that we looked at the UML wasn't the complete UML. So we were going to add pieces gradually to it. So the rectangle part is complete, just the class name at the top. But the fields that we have, we are going to put the data type for those fields by putting a colon and then the data type. Okay. And that's just how you write it in a UML. So you'll see the name of the field, colon, and then the data type. And then we are going to put whether those fields are public or private based on we put a minus sign whenever it is private and a plus sign whenever it's public. Now, those fields are typically going to be private, so typically the fields will have a minus sign before them, okay? Now, it's the same thing for the methods. You're going to put a plus or a minus sign, and typically your setters and your getters will be public so we can access them, so we'll have a plus sign before it, okay? That tells whether it's private, public, or private. So plus is public, minus is private, okay? Then you'll have the name of the method, and then in parentheses, you'll have the parameters. Now, if there aren't any parentheses, just leave it empty, okay? Now, if there are, you will say the name of the parameter and the data type. And then you'll put a colon and you put the return type. So if it's not returning, it's void. And if it is, it'll have a different data type of what it's returning. Okay, so that is how you do a UML diagram. Does that make sense to everybody? And of course, you would have more on here. And I already went through this. So how does that translate? So first, you should do the UML diagram, okay? And that's your thinking process. So just like when you do code, hopefully you think about what you're going to do before you actually write it. You do a little pseudocode. You write it down. Like, first, I'm going to input this. Here's my calculation. Then I'm going to output this, right? And then what do I need to repeat? Like, this part should get looped. Or sometimes you may need like a flow chart of like, okay, this is what my loop is going to look like. And these are my decisions that I'm going to make if it's more involved. And so for when we're talking about object-oriented, we have UML diagrams. And sometimes we'll have more classes and we'll say how they're related. But for now, we just have this UML diagram and we write the class and the fields and the methods, okay? And once we have that all finished, like let's say this is finished, this would translate into code for us, right? So how does it look? Well, the class name goes at the top, the fields go at the top of your class, and then all the methods go underneath. Now, the order of the methods, to me, it doesn't matter. Like whatever order you want to put them in. Again, I said, if you want to go down through each field and take the first field, do setter and getter for it, and then the next one. Or if you want to just handle all the setters and then all the getters and all the calculations, whatever makes sense to you. It just has to be inside the class after the fields. Ready, following? Over? Okay. All right, so this is a completed UML diagram with what we have so far. So here are the fields, and you can see that, again, the minus sign means that's private. It says the data type for each of the fields. And then here, all of these methods are public, so we can access them with a plus sign. The name, some of them don't have any parameters, and those are the getters because they don't need any information from you. And the getters will have return types, but the setters will be void. Can everyone follow that? You should lay that out before you do the code. So we could just jot down real quickly what you have. Now, I guess like if you're not giving this to someone else to follow, you could probably just write down the fields and then figure out the data types as you go. But if you are giving it to someone to figure out, you do need to write all of those if they're private or if they're public. And so people can relate this to what the code would actually look like, okay? So the code for this would look like this. The class will go up here. The fields will go at the top. And again, they're private, so you have private. Then your setters, and we don't have the actual code in there. I think that's in the next slide. But here's the way the method declarations look like. And these shouldn't be just return 0. Change that, okay? But the method declarations are correct. There we go. That's better. So we take whatever parameter we have here and we put that in the field name. And again, I told you, try not to give your field names the same name as your parameter, because then that's called shadowing. And what happens is it doesn't know which one you're talking about. So if you're in the method, it defaults to the parameter, not the field. So then you have to specify that it's the field, not the parameter, by saying this dot the name of the field. You don't have to say this dot the name of the field if you don't give them the same name. Okay. So if you give them different names, then you can just use the names you gave them and you're good. Okay. Here, use the field names, don't use the parameter names, like when you're returning. And then this one's a calculation. Is everyone okay with that so far? Just make sure you can look at the UML that we have and the class, and that makes sense so far. I know sometimes like this is probably the first time you've seen this, and sometimes you're like, wait, what? So if you have any questions, just let me know. Everyone's okay? Okay. Again, I don't have any particular grouping that I need you to do. I just need you to have your your fields at the top, and then your methods, whatever order you want to put them in is really up to you. Okay. Just try to do documentation for each of your methods by doing the /*** and hitting enter, and then just filling in the description for your parameters and your method. Okay. We talked about this word instance. So instance just means object. So sometimes people call them like object methods, object fields, but then sometimes people are fancy and they call them instance fields and instance methods. Just know that instance and object mean the same thing. It's just kind of a fancy word if you want to confuse somebody. Then it's a good word to use. And again, if you want to be fancy and say you're instantiating an object or instantiating a class, if you want to be really fancy, or not instantiating an object, because that is creating objects. Instantiating a class, you're just creating an object of the blueprint. So that's all you're doing. So it kind of sounds fancy though. Okay. Whenever you write your variables for your fields, these fields wouldn't be static. You can make variables static though. If you make the variable static, that means that it doesn't go with the object, it goes with the class. So what would you do? We're going to try this a little bit later. I think it's chapter 8 actually that we'll worry about this, but an example of this would be, so if you're doing rectangles, each rectangle field, like length and width, each rectangle would get a length and width, right? So those wouldn't be static because if so, that would go with the class and they're not all the same length and width. So it makes sense to just have a length and width that went with the class, not to the rectangle. Okay. So we need each rectangle to have its own length and width. So that means it's non-static because it each goes with each object, okay? But if you have a static field, like for example, I usually use a counter as a static field. If you were counting the number of rectangles you were creating, then you would make that static because it would go with the class and it would keep track of how many you have. Each object wouldn't have its own counter. It would just have one counter for all the objects. So if you just have one for all the objects, then it's static. But if each object has its own, then the variables are non-static, okay? And if they're non-static, we don't write the word static. And if they're static, we write it. But typically for now, at least for now, and later we'll add some static ones, we're gonna make all our fields, the fields, non-static. So just don't write them static. Everybody with me? Okay. Okay, and I have a code example I'm gonna show you of everything kind of tied together. So if you were wanting to create, I talked about this before, like if you were creating a blueprint for building houses, your community can have many houses created off that same blueprint. Each house doesn't have to have its own blueprint. You can still make them look different. And so just because it's created off the same blueprint doesn't mean, like, let's say you build a house, right? And have the same layout as your neighbor's house, right? But you can paint like the colors and have different furniture in that house, and you could change things, but it doesn't have to be exactly the same. But it can have the same blueprint. Okay, so I can create many different things off the object. So like I can have different rooms if you're talking about rooms. Okay, and then each one of those, like if you had a kitchen object, it would have its own length and width, and then the bedroom would have its own length and width, and then the den has its own length and width. So each of these fields goes with the object that it has, so that if you take that kitchen object, then the fields go with it. Does that make sense to everybody? So it knows that information. Okay, so let's take a look real quick before we get into constructors at the code that we've been talking about. And so I have this example. You should have this example inside your course notes folder. And so instead of making you type all this, you have all this code. If you get the course notes from Canvas and you download and extract that, if you go to chapter 6, you should have this rectangle example. Okay, so here, and worried about that. Okay, so here's my blueprint for rectangle. So you can see public class rectangle. Here are my fields. Again, we talked about setting those at private. Notice how the word static is not on there. Okay, and then I'm going to worry about that in a little bit. That's the constructor. So I'm going to go down here to the setter. So I have a set length. See, the setter is void and it takes in the data. It saves this as the field value. And then I have a set width, and then we have, documentation for each of these. You have a getter for the get length, a getter for the get width. Is everybody following this so far? Except for the constructor part. Okay. And then the get area we talked about is here with the calculation. Okay. Now over here, what we have, and we're going to talk about this in a bit, is a rectangle being created. And you can imagine this without even thinking about the constructor right now, hopefully. That's going to create an object called box. And it's going to have 5 as the length and 15 as the width. Okay, now when you want to print that, you would refer to whatever you named the object up there. So if you called it box, you would say box. You always have to say the name of the object. So that's the other thing I forgot to mention. Over here, you notice how none of the methods I created have the word static? That's because, sorry. If you think about it, you can't change the width of a rectangle or get the width of a rectangle or the length or get the area if you don't have a rectangle, right? So you need to have a rectangle object in order to do those things because it doesn't make sense. You can't do those things without an object. You need to have an object first. So if you need to have an object in order to set the length of a rectangle, then you would call that non-static. So you see how none of them have the word static? Because you need to have an object in order to modify a length, or you need to have an object in order to get the length of it, okay? So you don't have static on any of these methods, okay? So over here, when you want to do get length, when you want to figure out what the length of the object is, you have to see the name of the object, which is what you gave it up here. And that's what we're talking about. Do you have to create an object before you use the method? Yes. If you try to use this method without having an object, if I didn't do this line here, could you do it? No. If you don't have an object, you can't get the length of an object. Does that make sense to everybody? Okay. You cannot set the length of an object if you don't have the object. You can't get the area of an object if you don't have an object. So you need to create an object. That's the first step. So you create the blueprint, then you create the object, and then you can use the methods that go with the object. Is everybody kind of following that? You can create as many objects as you want. So right now I just have one object named box, but I could create 20 more if I wanted to, okay, with different lengths and widths. And then I can use those objects and I could say, you know, get the length, get the width, set this, set that, right? Get the area. Okay, is everybody okay so far? Okay, perfect. All right, so constructor, talk about this in a basic sense, okay? And we're gonna practice with this over and over and over again. So if you remember the whole always thing, I told you like, I like to use the word always and then I go back and change and say like, well, not always. Usually, that's why I say usually methods start with a lowercase letter, like getters and setters and the calculation methods that you have, but they don't always start with a lowercase letter. So constructors are going to be called whenever you create an object, okay? And so they are going to have the same name as the class. And your class starts with a capital letter. So if they have the same name as the class, then your constructor is going to start with a capital letter. So it's one that doesn't follow the rules because the constructor is a method, but is the same name as the class. Okay. Now, what's the job of the constructor? The job of the constructor normally is to set up the object, okay, with any incoming information that you know about the object. Okay. So like if you have a rectangle, instead of creating a rectangle where the length and the width are 0, and then going and have to set the length of the rectangle, and then going to have to set the width, that doesn't make sense, right? Because I know it's only 2 fields, right? But imagine it's 20. Wouldn't that be a pain? If you had to like create every object and then go set all 20 properties, it's like there has to be an easier way. Wouldn't it be nice if you had a constructor where like you create a rectangle object and you could just pass in the length and the width and it would automatically set that? You wouldn't have to call the setter and the getter, or I mean, not the setter and the getter, but the setter for each of them. Okay, so this is how we do it. So it looks like this. I think I'll just show you the code for this. And we can come back and make sure that makes sense. So this is what I was talking about here. Instead of leaving it be 0, instead of leaving it be empty, right? You can pass in the length and the width. And where does that go? Let me show you. So this is called a constructor. Don't worry about that one down there. Let's just focus on this one right here. So see how it has the same name as the class? Okay, it's going to be public because otherwise you can't access it. Okay, now rectangle has to match the name of the class. So that's a method that doesn't follow the rules because it starts with a capital letter, right? Now, whatever data you want to allow the user to pass in when they're creating the object, you would put in parentheses there. So if you want them to be able to set the length and the width of the object, you would put that in parentheses. That make sense? Okay, now you would this would look like your setters that you have. Now, you can, if you want to, just call your setters that you already have, especially if your setters have validation in them, so you don't have to rewrite it here. Like right now, I don't have validation. Does everybody know what I mean by validation? Like make sure it's not a negative number or anything like that. So I'm not checking that to make sure it's not a negative number. And I wouldn't want a negative number in there, but I'm going to do that eventually. I'm just stepping through step by step. So if I did that logic in my setter, then I could just call the setter right here instead of putting the, you know, the code again in here. Okay, so what this is going to do is set it up so that when you create the rectangle, you're saying I'm going to pass in 5, and you don't have to do this. It's kind of bothering me. I just think it's extra to look at. It's going to make an integer into a double without putting 0.0. So 5 and 15, right? So 5 is going to go into LEN, and 15 is going to go into W. So then that's going to get set as the length for 5, and then 15 is going to get set as the width. Okay, does that make sense to everybody? All right, so then I don't need to call the setters for those two things, the length and the width, and it saves me time. I know it's only 2 fields, but imagine it was more, because 2 doesn't sound like a lot, but like 20 or 40, that's kind of a pain. I'd rather just put them right here and get it done with. Now, you might say, if I can just set them when I create it, why do I have setters? Like, what's the purpose of a setter then? The purpose of a setter is, well, in case you do leave it blank, which I'll show you later how you can do that. But if you want to change it later, how would you change it if you didn't have a setter and the fields were private? So if, let's say I create with 5 and 15, but I want to modify it later. So let's say it's a room and I knock out a wall and it changes size, right? I can't change the size if I don't have a setter. Like when you create the object, you can't like recall the constructor to change it. You have to call a setter to change it. Like the constructor only happens when the object is created, and you don't want to keep creating new objects, like because things change. You want to modify the existing object. Now, if your fields are private, you can't modify them, and you can't modify them through the constructor once it's already created. So if you don't have a setter, you can't change them in the future. So if something isn't supposed to change in the future, then yeah, you don't need a setter, I guess. But there's not a lot in this world that doesn't change, right? And so if it's going to change, it needs to have a setter to be able to be modified. Does that make sense to everybody? Okay. So anybody have any questions so far? We'll continue with like what's a default constructor and how to have different constructors, like overloaded constructors in the next class, because I don't want to overwhelm anyone. So if you try to just take in what we did so far, try to make sure you really understand setters and getters, because they're going to be here for good, and fields and how we do, you know, private fields, hopefully, and the purpose of why we have the setters and getters, and then just a very basic introduction to constructor, because we'll talk about more about constructors in the next class. Okay, very good. Try to make sure you're reading the chapter because I don't know if hearing it just like one time is gonna, you know, make complete sense. So make sure you are looking over this chapter. And again, you have this example on Canvas if you want it. All right, let me stop this.